Hello everyone, welcome to my channel India Gate. This is Nandani Sharma, and in this session of the NIC or NIELIT, two posts, that is your scientific B and scientific technical assistant A. So here I representing the 40 plus most important MCQ of the database with solution. Okay, and this session is most important for all Scientist B and Scientific Technical Assistant applicants. So let's get started. Here first question, consider the entity hotel room and person with many-to-many relationship lodging as shown below. So here AR diagram is given below. Now basis of this AR diagram, if we wish to store information about the rent payment to be made by persons occupy different hotel rooms, then this information should appear as an attribute of. So this is the attribute of the option C, means your lodging. Why? We come to the here solution. Okay, so here more information about this question is given, like it is an many to many. Okay, so rent can be an attribute of room or person entities alone. Okay, so it depends on the number of persons sharing a room. The rent for each person for the room will be different. Okay, otherwise rent can be attribute of the room, hence attribute is lodging. Okay, lodging is your correct answer. Now come to the next question. Consider the basic AR and the relational model. Which of the following is incorrect? So there are four options, and option A, an attribute of an entity can have more than one value. Yes, it have more than one value, so it is correct statement. Now come to the next statement, option B, an attribute of an entity can be composite. Yes, it can be composite. Next option C, in a row of a relational table, an attribute can have more than one values. No, it is incorrect. An attribute have only one values. Okay, come to the next option D, in a row of the relation table, an attribute can have exactly one value or null value. So it is your correct statement. So we directly say that option C is your incorrect. Okay, so option C your correct answer for this question. Now come to the next question, state true or false with reason. So here there is also a composition into wise called normal form that is lossless and dependency preserving. Okay, so it is a false statement. How? Come to the solution. Why? Because sometimes there is no decomposition into the BCNF form. Okay, that is the dependency preserving. For example, consider the relation schema A, B, D. If we have the function dependency AB to D and D to B, then ABD is not in BCNF because D is not the key. If we try to decompose it, however, we can't preserve the dependency to AB produce D. So we say that this statement is your false. Okay, now come to the next question. Which normal form is considered adequate for the normal relation database design? So there are four options. Option A 2NF, option B 5NF, option C 4NF, and option D 3NF. So we say that option D is your correct. How we come to the solution here? Here there is not always a decomposition into the BCNF. That is already we considered in the previous question. Okay, that is lossless and dependency preserving. So third NF is considered adequate for normal relationship database. Okay, so option D is correct. Now come to the next question. Here table is given as name and attributes are there are 4 columns: name, age, occupation and category. Okay, so basis of the attributes Ram, Rama, Abdul, Jennifer, Maya and Dev, they are all the attributes defined basis of the given entities. Okay, so here question is asked, there is an index file associated with this and it is contains the value 1, 3, 2, 5 and 4. Which one of the field is the index will form? So there are 4 options. Option A is, option B name, option C occupation and option D category. Now come to the solution. Here solution is given like the index is built from field occupation where con is equal to 1. Okay, the value, and here E and G is equal to 2 index values, and here DOC is equal to 3 index value, and SER is equal to 4 index value, and MU is equal to 5 index value. So basis of the occupation, it is a correct answer. So option C is your correct field. Okay, now come to the next question. Let R is equal to A, B, C, D, E and F. We are relation schema with the following dependency: C produce F, E produce A, EC produce D and AB produce B. Which of the following is a key for R? So it is very easy questions. Okay, and there are 4 options: option C, D, option B, EC, option C, AE and option D, AC. Now come to the solution of this question. Okay, so correct answer is option D, option B, where is defining the, we choose the correct option for finding the closure of each option. Okay, we know that if we find the key, so we firstly find the closure of each option. So firstly find the closure of CD, that is option A. Then we get here CD produce, the closure of CD produces CDF. So CD is not a key, because if the CD contains all the elements of R, then it is called the key element, but it's not contained, so CD is not correct answer. Now come to the next question. Options. Option B. So we get here, in the case of the option B, we produce all the elements of the R. So we say that here EC is your key, and in the case of C and D, we can't be produce all the elements of the R. So we easily say that option B is your correct answer. So EC is your key for R. Okay, now come to the next question. Consider a schema R contains A, B, C, D element and function dependency A produce B, C produce D. Then decomposition of R into R1, AB, R2, C, D. Okay, is, so there are 4 options. Option A, dependency preserving and lossless join. Option B, lossless join but not dependency preserving. Option C, dependency preserving but not lossless join. And option D, not dependency preserving and not lossless join. Now correct answer is option C. How? Come to the solution here. So solution is given like, we already know about that R produce, R having the element A, B, C, D, and here 2 partition of the R, R1 and R2. Now we firstly find the function dependency of R1 and R2, which is already given, that is A produce B and C produce D for the F2 and F1 respectively. Now all the original functional dependency can be derived from F1 and F2, hence the decomposition is dependency preserving. The attribute P doesn't functionally determined either A or C or D. The attribute D doesn't functionally determine either A or B or C. Okay, so it is not lossless join, but it is your dependency preserving. So option C is your correct answer. Now come to the next question. Here next question. Relation R with an associated set of functional dependencies F is decomposed into B, C and F. The redundancy arises out of the functional dependency in the resulting set of relation is what? So correct answer is 0, because we know that the redundancy in the resultant set of relation is always 0. Okay, so it is most important point. Okay, so you have to consider this question also. Okay, now come to the next question. Consider the following relation schema pertaining to student database. Here student contains roll number, name and address. Enrollment contains roll number, course number and course name, where the primary key are so underlined. The number of tuple in the student and enrollment table are 120 and 8 respectively. What are the maximum and minimum number of tuple which can be present in student star enrollment number, where star is denoting your what? That is your natural join. Now there are 4 options. Option A 8,8, option B 128,8 and option C 960,8 and option D 960,120. Okay, now come to the solution. Here option A is correct. Why? Because we know that here the relational is student and enrollment is unique. Okay, unique things is your roll number. Okay, in the given things. Okay, roll number and course number. Okay, each record of the enrollment can be mapped to one record of the student based on the natural join condition. Okay, so the maximum 8 tuples in a natural join and the roll number of the enrollment foreign key reference to the student. So minimum also 8 tuples in a natural join. Okay, so due to of this reason option A is your correct. Okay, and correct answer is maximum is 8 and minimum is also 8. Now come to the next question. Which one of the following statement about the normal form is false? So option A, PCNF is stricter than 3NF. So it is your correct statement. Now come to the next statement. B, lossless dependency preserving decomposition into 3NF is always possible. Yes, it is always possible because it is already discussed in above questions. Okay, next question, option lossless dependency preserving decomposition into BCNF is always possible. No, it is never possible in the case of the BCNF. Okay, now last, any relation with two attribute is BCNF. Yes, it is the attribute is BCNF. So option D is also correct. So we say that easily the option C is your incorrect. Next question, which of the following statement is false? So there are 4 statement and options. Option A, any relation with two attribute is in BCNF. Yes, it is in BCNF. So option A is correct. Now come to the option B, a relation in which every key has only one attribute is in second NF. So it is correct also. Now third option is defined as a prime attribute can be trivially dependent on a key in a third NF relation. So it is also correct. Now last question, which is must be false. Okay, so a prime attribute can be trivially dependent on a key in a BCNF relation. No, it is false statement. So option D is your correct answer for this question. Now come to the next question. Which of the following is true? There are 4 options. Option A, every relation in the third NF is also in BCNF. No, it's not be mandatory. Third NF is also in BCNF. Okay, so this is false statement. Now come to the option B, a relation R is in third NF if every non-prime attribute of R is fully functionally dependent on every key of R. So it is also false, and this is also false statement. Now come to the C option. Every relation in BCNF is also in third line of yes. According to given hierarchy, every relation in BCNF is also in third line. So this is correct statement. Now automatically we say that option D is also false. Okay, so option C is your correct statement. Now come to the next question. Consider the relation scheme R which contains E, F, G, H, I, J, K, L, M, N elements and the set functional dependency related as E, F to G, F produce IJ, E, H produce KL and K produce M, L produce N on R. What is the key of R? Okay, so here correct answer is option B, E, F, H. Why? Because we know that a set which contains all the element of the R schema or relation, that is called the key of the R. Okay, so basis of this fundamental we say that option B is correct. Now come to the next question. So next question is defined as a prime attribute of a relation scheme R is an attribute that appears. So there are four options, option A, B, C and D. So correct answer is D. B. Why? Because we know that the prime attribute of a relation scheme R is an attribute that appears in some candidate keys. Okay, so option B is your correct. Now come to the next question. Consider a relation X which contains P, Q, R, S, T, U with the following set of the function dependency. Okay, here P, R produce S, T and P, S, U produce Q, R. Okay, which of the following trivial functionally dependency is F closure, or we say that closure of F? So there are four options A, B, C and D, and correct option is option C, PS produce S. Okay, now come to the solution of the. Okay, so basis of the option C we know that here PS produce S is a trivial function dependency, because here PS is proper subset of the S. So due to of option C is your correct answer. Now come to the next question. Which of the following is not a super key in a relation schema with attribute V, W, X, Y, Z and prime key Vy? Okay, so is it very easy question. Why? Because we know that a prime key is always included in any relations, and here all the option, like option A contains Y, V and Y also, and in the option C V and Y also included, in option D V and Y also included, but in the option B V is included but Y is not included. So due to of this reason option B is your correct answer. Okay, so basis of this question option B is your correct. Now come to the next question. And here also the explanation also given there. Here VWXZ no complete candidate key exists, so it is not a super key. Okay, this is the good solution for our question. Now come to the next question. Consider following SQL query. Select distinct A1, A2 and so on AN times. Okay, from R1, R2, so and RM times. Here we are okay, for an attribute predicate is representing this query is equivalent of the which of the following relation algebra expression. So here giving the expressions A, B, C and D. Okay, so correct and right expression for the given above SQL query is your option A. Okay, because firstly we project, then select the from R1 R2 schema. Okay, so option A is your correct. Now come to the next question. Which of the following statements are true about SQL query? Okay, so there are 4 statements, and statements are given. Statement P: an SQL contains a having clause even if it doesn't have a group by clause. Next, option Q, and statement Q: an SQL query can contain a having clause only if it has the group by clause. Statement R: all attributes used in the group by clause must appear in the select clause. And statement S: not all attributes used in group by clause need to appear in select clause. Okay, so there are 4 options. Option A P and R, option B P and S, option C Q and R, and option D Q and S, and we find the true statement. So basis of the given option, Q and R is your correct statement. Why? Because we know that an SQL query contains having clause only if it has group by clause. So it is your correct and true statement. And R is also correct. All attributes used in the group by clause must appear in the select clause. Okay, without select clause, group by clause is not be possible. Okay, so option R and Q is your correct answer. Now come to the next question. Which is the optimized version of the relational algebra expression? Project A1, project A2, select F1, select F2 from R, where A1, A2 are the set of the attribute in R, and A1 is the proper set of A2, and F1 and F2 Boolean expression based on the attributes in R. So there are 4 options, option A, B, C and D. And here correct answer is option A. Why? Because basis of the given option A is your correct representation and Boolean expression based on the given attributes in R. Okay, so option A is your correct. Now come to the next question. And here explanation is also given for the above why it's 1. Okay, so basis of the year project A1 and project A2 is A2x is also equal to here project A1x, since A1 is the proper subset of A2. Now secondly we say that project F1 and project F2x is equal to your project F1 and F2x. Okay, select. Okay, so basis of the selection and projection basis, we easily say that the option A is your correct answer. Okay, now come to the next question. Select operation in SQL is equivalent to. So there are 4 options. Option A, the select operation is in relation algebra. Option B, the select operation in relation algebra except that select in a SQL retains duplicates. And option C, the projection operation is a relational algebra. And option D, here the projection operation in relational algebra except that selection in a SQL retains duplicates. So we say easily the option D is your correct answer. Okay, now come to the next. Consider the following relation: cinema, which contains the attributes theater, address and capacity. Which of the following selection will be needed at the end of the SQL query. Select P1 dot address from the cinema P1 such that it always find the address of the theaters with maximum capacity. Okay, so there is a question is already given. Okay, we found the correct expression for this relation. Okay, so we say there are four options, option A, B, C and D, and correct answer is option E. Okay, we use where P1 capacity is greater than all. Select P2 dot capacity from cinema P2. Okay, so option A is your correct answer. Now come to the next question. Given the relations employee having the entities name, salary and department as the attributes, and the department having the attribute department name, department number and address, which of the following query can't be expressed using the basic relational algebra operation? Select project, Cartesian, join, union, intersection and difference. Okay, so there are four options, option A, B, C and D. Okay, so these are the given the options. Now basis of the option we say easily option C is your correct. Why? Because here the sum of the all employees salary, it is not the basic relational algebra. Okay, operation. Now come to the next question. With regard to the expressive power of the formal relational query language, which of the following statement is true? So there are four options, option A, B and C, D. Okay, so basis of this statement we easily say option C is your true statement. Why? Because we know that relational algebra has the same power as the safe relational calculus. Okay, so it is your correct statement and true statement. Now next question. Consider the relation R1 having elements PQR and R2 having element RST with primary key P and R respectively. The relation R1 contains 2000 tuples and R2 contains 2500 tuples. The maximum size of this join R natural join R2 is. So it is very simple because we know that in this case R1 contains 20,000 tuple and R2 contains 2500 tuple. So we easily say the maximum size of this join is 2000. Okay, we consider only common terms between the R1 and R2, and 2000 is common between the R1 and R2. So we say that 2000 is your correct answer. Next question. Which of the following scenarios may lead to an irrecoverable error in the database system? So there are four options, and option A, a transaction writes a data item after it read by an uncommitted transaction. So it is not correct. Now come to the option B. So option B, a transaction read a data item after it is read by an uncommitted transaction. So it is also incorrect. Next, option C, a transaction read the data item after it is written by the committed transaction. It is also incorrect. Now we say according to question, irrecoverable error in the database system is your option D. Okay, why? Because in the case of the transaction read the data item after it written by the uncommitted transaction, so it is an irrecoverable error. Okay, in the database. So option D is correct, and all the A, B, C is are recoverable errors. So we say that option D is your correct answer according to a given question. Okay, now come to the next question. Which level of locking provides the highest degree of the occurrence in the relational database? Okay, so there are four options. Option A, page, option B, table, option C, row, option D, page, table and row level locking also same degree of concurrency. So we say that here option C is your correct. Why? Because here the row having the greater and highest degree from page and table, but here degree of the concurrency for page and table is equal. Okay, so we say that option C is your correct answer. Okay, now come to the next question. Amongst the acid property of the transaction, the durability property requires that the change made to the database by a successful transaction persist. So there are four options: option A, B, C and D, and correct answer is option D. Why? It is very simple, because we don't have always every if there is a failure of any kind, so durability is your fourth property of the database is work. So there is a successful transaction is persist always, even if there is failure of any kind. Okay, so option D is your correct answer. Now come to the next question. Here, which of the following concurrency control protocol ensure both conflict serializability and freedom from deadlock? So here, first, that is your two-phase locking, and second, time stamp ordering. So we know that in the case of the time stamp ordering, it ensures the both conflict serializability and freedom from deadlock. So option B is your correct. Miss only second is correct. Okay, now come to the next question. An index is clustered if, so there are four options: option A, B, C and D, and correct answer for this question is option C, because we know that about the index is clustered, the data record of the file are organized in the same order as data entries of the index. Okay, so option C is your correct. Next question. Let R1 having A, B, C elements and R2 having D and E element be a relation schema where the primary key are shown underlined and let C be a foreign key in R1 referencing to R2. Suppose there is no violation of the above referential integrity constraints in the corresponding relation instances R1 and R2. Which one of the following relational algebra expressions would necessarily produce an empty relation? Okay, so there are four options: option A, B, C and D. So correct answer for the above question is option B, because only this here project C from R1 difference project D from R2, it's also produce the empty relation. Okay, so option B is your correct answer. Now come to the next question. Which of the following relational query language? So there are three statements are given. First is your relational algebra, second is tuple relational calculus restricted to safe expression, and third domain relational calculus restricted to safe expression. So correct answer is option C. Why? Because here the relational language query language having the same expression power. So here all of three are correct. So option D is your correct answer. If you have any queries, so please comment me. Thank you for watching.